Hello everyone, Mr. Kennard again. This is lesson 9.1, session 1. It's talking about substance models. To review a little bit, we've just finished up with investigations 1 and 2, and in those we were looking at the mystery mixture and looking at white substances that made up the mystery mixture, 2 of which. And then we figured out all those substances are made up of different kinds of what we call elements, and those elements are organized in the periodic table. And from that, we were able to see how many different elements, many of them common, many of them rare, where they came from. But they are what make up everything in the universe. Everything on this planet, other planets, other galaxies, star systems, everything like that. So what we're going to focus on here is to look at some of those elements in their basic form, what makes them up, and how they create these common substances. So before we look at all that, we need to review a little bit about what is a substance. Every substance, we said, has a unique form of matter and has unique properties. So that makes them special. So when we looked at all of those white substances, yes, they were all white. Some of them were crystals, some of them were powder, but they were all unique in their chemical formulas and in their chemical names, and in their even common names. Salt and sugar look alike. I don't think you want to put salt in your coffee or tea or mix that in your iced tea or something like that. That probably wouldn't be good. So make sure that you look at that. But they have unique properties. The second thing is, all substances, we said, were made of elements. And those are the basic building blocks of all matter, no matter what kind of matter it is. Solid, liquid, or gases are all made of elements. The substances, are defined by the kind and numbers of the elements in each of them. We looked at some of those. They had carbon and hydrogen and oxygens and sodiums and chlorines, etc. And the types of elements that are in a substance and the numbers of those elements are in a substance make a big difference. I don't know if you noticed in some of the white substances, the only thing that made a difference between one type of substance and another one was how many O's there were. One was 7, I believe, and one of them was 8, and that one little difference makes a big difference. Again, remember, they were letters that made up words, and by adding an extra O, the word TO now becomes TOO, and that makes it a different use of that word. Moving on, can be made of one element by itself, or 2 or more bonded together, and that's what we're going to focus on in this lesson. And finally, it can be represented by a chemical formula. What makes that substance is its chemical formula, its chemical name, and then its more common name that we refer to. So here again, all substances are made of those basic elements. And the periodic table had over 100 of those elements. Some are very common, some are very rare. Hard to find many of them. Overall, the particles of the elements, they combine to make all of the substances we say. Remember I said elements were like letters, and the substances are like words. The building blocks of words are the letters, and how many and how different types there are of the letters can make different words. I could make words, or I could make a sword just by moving the S in front of that. Lots of different things to be able to do that. Well, what's the basic building block of letters is actually something called an atom. The atoms that make up the elements. Think of them as like the letter strokes in making a letter A or a B or a C. Some of them are similar, some of them are much different. But those are the basic particles of all elements are the atoms. And we'll talk about those a little more in detail a little bit later. I like to teach in analogies, and one of the things that I always like, we talked about the letters and words. Letters of the elements make up words of the substances. Well, you can kind of think of the same way as each element, because each element has its own unique atom. And the way I like to think about it, or explain it sometimes in my classes, if you ever watch one of those dog shows, the Westminster Kennel Club or something like this, you probably never do, maybe in flipping channels or something, but you should check it out. If those are all purebred dogs, a German Shepherd, a Rottweiler, a Pekingese, a Cavalier King Charles Spaniels, each one of those breeds is unique. We know a Dalmatian, when we look at a Dalmatian, it's got certain unique characteristics. And a German Shepherd looks a certain way, and a Shih Tzu looks a certain way, and a Chihuahua looks a certain way. That's because those are unique, and each element's atom is also unique. It is unlike any other. But they all look the same. So if I had an oxygen atom, all the oxygen atoms would look alike. All the hydrogen atoms would look alike. All the calcium atoms would look alike, much like all Dalmatians look alike, or Chihuahuas are looking alike, etc. So think of an atom of an element as like a purebred dog of that breed. Maybe a way to think about it. So every element in that periodic table that we looked at has its own unique atom. It's special unto itself. Now, we can't see atoms, but so we put representations of what these atoms look like. I've got a little picture here next. You're going to see different atoms, and we're going to give them different colors so that they can stand out, and we're also going to put their symbol in them. So let's look at those. We're going to represent atoms as little circles with their symbol in them and give them a color. So when we focus on these things, all oxygen atoms will be red in color with an O in the middle. And H's are hydrogens, and they'll have an H for their symbol in the middle there, and they'll be blue. Chlorine is a Cl, and it'll be a green. Carbon is an orange one with a C in it. It'll be an orange one. Na is for sodium, and that's a yellow dot, and this one up here is Ca, and we can go on and on and on. But each one of them will have a different color and for our representation, and have their symbol in them. And honestly, these are all uniform size. The size of atoms is also different depending on what kind of atom it is as well. Just again, like breeds of dogs. You have small dogs like Chihuahuas and large dogs like Great Danes. So we're going to use these as our representations of what we perceive the atoms to look like, and it'll make it easier to see how they combine. And that becomes our focus question. How do atoms combine to make new substances? How is it that we take those letters and make words? That's going to be our focus question for this lesson. Here's a representation of a new particle. Particle in this case has two. I'm kind of giving away the answer. How many atoms have combined, and how many kinds of atoms have combined? Well, atoms in this case are the circles. So how many circles do you see? There's two. Well, how many kinds of atoms have combined? Well, notice in this, they're both red, and they're both an O, so that means they're both oxygens. So it's only one kind of atom. So there's two atoms, this one and this one, but only one kind, not kids, goodness, can't write, one kind of atom, and that being oxygen. So even when we have two or more atoms of the same kind combining, that substance we still call an element. Any substance that is made of only one kind of atom is that element. So in the previous example, we had two oxygen atoms together. Now you may think, well, that's two different elements. No, they're still oxygens, and they're still together. So any of them that have any of the same types of atoms we refer to as an element. Now they may have different types of that same element. If you think of Chihuahuas or Labradors, you could have a black lab, a yellow lab, a chocolate lab, any of those. They're all labs, but they're all just a little bit different, but they still fall into that. Well, oxygen's kind of that way too. You can have a single oxygen atom. You could have a double oxygen atom like you saw there. That's actually what is the oxygen, the form it is, and we breathe in most often. And then on the next one, you'll see there's a third type of oxygen atoms joining together. In this example, this is a particle of the substance called ozone, and it's made of 3 oxygen atoms. So is ozone an element? And how would you know? Well, how many atoms of oxygen are there? There are 3 atoms. But how many kinds of elements? Well, only one kind of element. In that case, ozone is an element because only one kind. Now here's another one made of 3 atoms though. How many different kinds of atoms are in this particle? And is it an element? In this case, you can see that there's blue dots represented with the H, that's hydrogens, and the red dot represented with the O, that's oxygen. And there are 2 H's and 1 O. Is this an element? No, because it has 2 different elements in it. 2 different elements. They make up one particle of matter, and 2 H's and an O makes H2O, you might know. This representation of a water particle, like we talked about, is 2 hydrogen atoms and 1 oxygen atom. Any particle made of 2 or more different kinds of atoms, key thing there is different kinds of atoms, is called a compound. And most matter is compounds. If you think back to our letters and words, we said that letters combine to make words. There aren't very many words that are just made of one letter. Maybe I or A, or if you're texting, you can probably put U or Y, some of those kinds of things. But for the most part, we don't use individual letters in our writing. Most of them are combinations of letters. And that's what you're going to see with many things of compounds. They have different kinds of atoms put together to make big, more complicated substances. So as we saw before with our white substances, we saw chemical formulas. This is the chemical formula for water. It's H2O. And it's a substance tells us the number, how many, and the kind of atoms in one particle. So in one particle of atom, there are 3 atoms, and 2 elements. 3 atoms, 2 H's and 1 O, and 2 elements are H's and O's. The formula tells us that there are 2 hydrogens and 1 oxygen. So a little review question. How many of the substances on the periodic table of elements are compounds? Well, the short answer is none. None are compounds because each one of those is the elements. How do you know? Well, it's the table of elements, not the table of compounds. If at the top of the classroom board you had a list of the alphabet, that would be like the letters or the elements on the periodic table. That set of letters, 26 letters, makes up all the millions of different words. Our elements, our periodic table of elements, is what makes up all of the compounds when you join them and combine them together. So there are no compounds on the element table. How do we know? Because it's the periodic table of elements, not the periodic table of compounds. Let's go back to the mystery mixture. How many of the substances we used in the mystery mixture activity are compounds? Well, think about it. Ascorbic acid, sodium bicarbonate, calcium chloride, sucrose, dextrose, all those different ones. None of them were an element on their own, so all of those were compounds. How do we know? More than one element in each. Every single one of them had more than one element, C's and H's and O's and NA's and CA's and CL's, all of those. So all of those were compounds on the mystery mixture activities. A couple more things really quickly. One of the things that we talked about was there are 90 different elements and 90 different atoms, and these atoms combine to make new substances. If they're one kind of atom on their own, like oxygen and hydrogen that travel in pairs, that's one kind of atom known as an element. If you have 2 or more kinds of atoms together, 2 or more elements put together, those make up compounds like carbon dioxide. Carbon dioxide is here, and the NaCl, which is table salt. Then, now, how those are joined together, we're going to get into a little bit more detail. They are bonded together, kind of like wedding, holy matrimony, all that kinds of stuff. They're bonded. In this case, the bonds between H's and OCO, carbon dioxide, and hydrogens is a very strong bond, and that's a molecule bond. Whereas the other ones, like NaCl, that is a weak bond, and we call that an ionic compound. And we'll get into those a little bit more detailed later. So just to review, what are the basic particles from which all matter is made? We can say those are elements. Elements. And what's a compound? Two or more. Or more. My stylus is not working. Of those elements. What kinds of particles are made of two or more kinds of atoms? Ugh. Those are compounds. And what kinds of particles are made of just one kind of atom? Those are elements. And lastly, real quick, how are molecules and ionic compounds the same? They all are made of many atoms and elements. They're compounds. Both of them do that. And then how are they different? Well, by their strong or weak bonding. We'll talk a little bit about that more a little bit later. So that wraps up this session number 1. Session number 2 is we're going to look back at some of those common substances, those white substances, and figure out what atoms and how many there are based on their chemical formulas, and see how they're made up. Thanks for listening. Bye.